One macro, one missing pair of parentheses, one night of debugging you'll never get back. Let's get started.
Hey, welcome back. Open a window, let in fresh air, let's breathe clarity into our C++ code together. Are macros secretly sabotaging your C++ code? You might think they're convenient shortcuts, but these little helpers can unleash hidden disasters in your projects. Today I'm revealing exactly why macros can turn your clean code into a debugging nightmare and how to fix it. Alright, let's get right into it with a classic example. Imagine you need a simple way to find the larger of two numbers. You might think a macro is the quickest way to do it. Here's what's going on here. First off, we include the IOStream library so we can print our results, no surprises there. Now let's focus on this macro definition right here. This is what's called a function-like macro. Before your code even reaches the compiler, there is a tool called the preprocessor that scans your file. Whenever it sees your macro, it just performs a straightforward find and replace, swapping out the macro name with its defined expression. It seems straightforward, but here's where things get tricky. This isn't a real function. Now, looking inside our main function, we have two integers, one named x, set to 5, and another named y, set to 10. Next, we use our macro to find the maximum between x++ and y++. At first glance, you'll probably expect this macro to compare the numbers 5 and 10. See that 10 is bigger, and then increment both x and y once each. So logically, the result should be 10, x should be increased to 6, and y should be increased to 11, right? Well, now let's think about this for a second. Let's see what really happens when you run this code. You'll find that the result ends up being 11, x becomes 6, and y surprisingly becomes 12. This might look harmless, but here's a catch. It's all because of that direct text replacement we mentioned earlier. When the preprocessor replaces our macro call with its definition, it creates an unexpected expression involving those increments. And this is where the problem starts. Here's the step-by-step breakdown of exactly what your computer does behind the scenes. First, it compares x++, which is initially 5, to y++, which is initially 10. Since 5 is not greater than 10, the comparison evaluates to false. Now, because the comparison is false, the macro executes the second increment operation, causing y to be incremented again. At this point, y has already been incremented during the initial comparison. So now it increments a second time, becoming 12. The value that gets assigned to our result variable is the current value of y after its first increment, which was 11. Notice also that the x++ was evaluated exactly once during the initial comparison, causing x to become 6. Importantly, the second increment operation on x was never executed. This is a classic macro side effect bug. The variable y got incremented twice. This kind of unpredictable behavior can be a nightmare to find in a bigger project. So how do we fix this? We use a modern C++ feature that gives us the best of both worlds, an inline function. Now take a look at this much clearer version. Here's what's going on here. Instead of a macro, we've created a proper function. We've also made it a template function, which means it can automatically work with different data types, such as integers, floats, or doubles. Notice the inline keyword at the start of the function definition. This inline keyword is basically a suggestion to the compiler. It suggests that the compiler can directly place the function's code where it's called. This eliminates the overhead of an actual function call, making it just as fast as a macro. But here's the crucial difference. This is a real function. This means it follows the normal rules of C++ functions. So when we call our function using x++ and y++, both arguments are evaluated completely before the function actually runs. Here's how this plays out step by step. First, x++ is evaluated, incrementing x from 5 to 6, but the value passed to the function is the original value, 5. Then y++ is evaluated, incrementing y from 10 to 11, but passing the original value, 10, to the function. Next, inside our function, the comparison is performed between 5 and 10, with the function correctly determining that 10 is the greater value, which it then returns. When we run this version of the code, we get exactly the result we originally expected. Result is now correctly 10, x has become 6, and y has become 11. Everything is evaluated exactly once. It's predictable, it's type safe, and it's free from those nasty side effect bugs. By using an inline function instead of a macro, you get the efficiency you want without sacrificing safety and readability. Short and sweet. To really sharpen your skills, my masterclass at alcoacademy.com is the next step. Meanwhile, there's a ton more to explore right here on my channel. Smash that like button and leave a comment. I'd love your input.